If you remember what the word rational means, it means a number that can be represented as a fraction. Our unit now is the rational function unit, where now we're going to have polynomials that are written as division problems or as fractions. So just to refresh, we've actually had a rational function practice before where I've given you something like this, and you've had to simplify this. In this unit, we are always going to simplify. So just keep that in mind. If you can, you do. So we simplify this into 6 over 5. You have 1x up top, and you have 1y left on the bottom. Alright, so the first thing we're going to do with our rational functions is we're going to do some operations. And the first operation we're going to perform is multiplication. Okay, so this is a problem that I can give you. I can ask you to multiply these two rational functions and then simplify. So there's two ways you can do this. The first way is that we can multiply totally across and do 28 times 4 and get 112. And then we have y to the 5th left up top. Then we can do the same thing on the bottom and do 21 times 4 and get 84 y to the 3rd. Now what we have to do is we have to simplify this, so we have to keep going. Alright, so this is going to simplify, so 112 divided by 84 gives us 4 over 3. And then with the y's, you have 5 up top, 3 on the bottom, so you're going to have 2 left over up top. So that's the first approach that we can take to this problem. And I want to show you the other approach. It doesn't matter which one you do, it's totally up to you. Okay, so this other way, you can actually simplify within. So instead of multiplying 28 times 4, I see that I have a 4 in a numerator and a 4 in a denominator. So eventually, whether I multiply that 4 by 28 or not, since it's 4 over 4, they cancel each other out. And then I can see that I'm going to have 5 y's up top, 3 on the bottom. So the bottom totally cancels out. And then this 5 actually becomes y to the 2nd. And then you can ask yourself, okay, how many times or what numbers go into 28 and 21? Well, 7 goes into both of those. 7 goes into 28 4 times and 21 3 times. So my final answer is 4y squared over 3. I get the same answer, but this way up top, this way up here, takes a little bit more time than the way on the bottom, but at the same time, you might also see that the method on the bottom kind of gets messy. So however you want to do it, as long as it's simplified completely at the end. Okay, our next multiplication problem is filled with polynomials. Now, the golden rule to doing anything with these rational functions is to factor, because you will see that things will simplify. So you need to know how to factor. That's the first thing you're going to do first, okay? So in this first part right here, the numerator is already factored, so it stays x plus 1. And then the denominator actually factors into x minus 1 and x plus 3. Alright, now I'm not multiplying anything. All I'm doing is factoring and rewriting it in factored form. The numerator of the second part becomes x minus 2 and x plus 3. And then the denominator is a little bit different than the other denominator, having x plus 1 and x minus 3. Okay, so why do we need to do that? Well, if you notice now, when you multiply things, like the second part of the problem I just showed you, how you can cancel things out over the multiplication sign. So technically, I can get rid of this right here. I just got rid of that multiplication sign, and technically what I'm doing is I'm just mashing these things together. So I can just say, okay, well there we go, that's my whole problem. So now you have one numerator, one denominator. Now, you don't actually have to erase the multiplication sign and extend that divided by sign. It's just I'm trying to get you to conceptually see that it's the same thing. So now what we can do, which is the best part, is now we can simplify. Instead of multiplying these out and distributing, we factored so that I can go, oh look, x plus 3, x plus 3. What else do we have? We have an x plus 1, and we have an x plus 1. Nothing else can simplify, which means our final answer is x minus 2 divided by x minus 1 and x minus 3. Now, leave it in factored form. There's no sense in multiplying it all the way through at this point. The only other thing that we have to include when we do this is a domain restriction. You have to tell me what x can't be. So yes, that's the answer, but what can't x be? And if you remember, since it's a fraction, the denominator cannot be 0. So look right here. What in x minus 1, what's going to make that whole thing 0? Positive 1. Over here, x minus 3. Positive 3 is going to make that 0. So this is our final answer right here. Okay? The numerator is allowed to be 0, so that's not your domain restriction. You're only looking at the denominator. So this, your simplified form, which is in red, and then the orange domain restriction, that is the whole answer. You need both parts. Okay, so let's look at our third and final example for multiplying rational functions. Go ahead if you'd like and pause the video now and try it. The first step is to factor and then see what can cancel out. Alright, so when I factor the numerator, I'm going to get x minus 5 and x minus 5. In this denominator, I can factor it, but I'm going to factor using a GCF. I can take out a 10, and I'm left with x minus 10. The numerator over here stays the same, and the same thing happens with this denominator. I can factor out a GCF of 9, and I'm left with x minus 5. Alright, so I'm then going to say, okay, well, what can cancel? What are we going to get rid of? Well, I have an x minus 5 down here and here. I have an x minus 10 there and there. Now, something that some students always think is they don't have to be like diagonal from one another to cancel. I could have also had like the same thing right there on the numerator and denominator, and they can cancel out as well, just like that. So they don't have to be diagonal, but sometimes it's just kind of what happens. Okay, so my final answer, I'm going to get some more room up here. Get rid of our original. So now I'm going to start working from the top. Alright, so I have x minus 5, and now I have a 10 and a 9, and since we are multiplying, it's going to be divided by 90. Okay? Now, don't forget, you need to tell me what x can't equal. Well, here's the catch. Do you see an x in the denominator? Then therefore, x doesn't have any domain restrictions. We don't need to worry about that, because there's only a domain restriction when there's an x in the denominator, because that's the only way we could ever get 0 in the denominator. So this is our final answer for number 3.